Hello, this is Mr. Stansbury. I'm going to take you through the notes on regular polygons and exterior angles. Okay, at the end of this, you should be able to say, I can develop a formula for the measures of each interior angle of a regular polygon, and I can determine the measure of the exterior angles of a polygon. Okay, so first thing, a regular polygon is a polygon that has both all equal sides and all equal interior angles. So perfect example of that would be an equilateral triangle, a square, a regular pentagon, a regular hexagon, all that kind of stuff. Those are all regular polygons. Okay, so a square is a regular polygon. A rectangle is not a regular polygon. Okay, only because the rectangle is not all the sides are the same. So, oops. Okay, that looks a little better. So here's what we're going to do is we're going to fill out the rest of this table. If you'll remember, this here is the table that we filled out in the last set of notes. Okay, so what we're going to do is we're just going to keep this information going and figure out what this is here. So if we have a triangle, the total sum of the angles in the polygon of the triangle is 180. So measures of each of the interior angles, if it's a regular polygon, they're going to all be evenly distributed. So we're just really going to take, oops, got the wrong color here. There we go. 180 divided by 3 gives us that the measure of each interior angle has to be 60 degrees. So basically, if it looks, so here's our equilateral triangle, right? We're saying that each one of these here is 60 degrees. All right. Now the measure of each exterior angle. Here's what an exterior angle is. If you take any of these sides here and just extend it out like that, this here is going to be the exterior angle. All right. So we know that if this here is supposed to make a straight line, so we know that's a total of 180 degrees. That's going to have to equal these two angles added up, right? So 180 equals 60, and the, let's call it EA for the exterior angle, right? So we subtract 60 from both sides. So basically we're just taking away the measure of each interior angle, which in this case is 60. And that means the measure of each exterior angle of this thing has to equal 120, because we know that these two here always have to equal 180. Okay, and excuse me, then it asks for what's the sum of the exterior angles. So if each exterior angle is 120 and there's 3 sides, that means there's going to be 3 angles. We take 120, multiply that by 3, and that's going to give us 360 degrees. Okay, well, let's look at this one here. So this is our square. Let's see. So now we're going to take we have 360 degrees to divide evenly amongst 4 angles, which is going to give us 90 degrees. Okay. So then to find the sum of the exterior angle, we're going to simply just take 180 minus 90, right? 180 minus 90 is going to leave us with 90 degrees for each exterior angle, right? It's a square. It's got 4 sides, so we multiply that by 4, and we get 360 degrees for the sum of the exterior angles. Okay, so for 5, we're going to take our 360 total degrees. Actually, wait, I take that. Sorry, 540, because right here our 5-sided regular pentagon has 540 degrees. Divide that by 5, and we get 108 degrees for each interior measure of each interior angle of a regular 5-sided figure, which is pentagon. So then we take 180 minus 108, and we are left with 72 degrees. Now we take 72 degrees multiplied by 5. Guess what we're going to get? 360 total degrees. Okay, so hopefully you're starting to figure out what the pattern is going on this. Okay, if we take 6 has got 720, divided by six equal sides, sorry. That is going to leave us with 120 degrees. So this is 120. So if we take 180 minus 120, that's going to leave us with 60 degrees. Multiply that by the 6 total exterior angles. 6 times 60 is 360 degrees. Okay, 900 divided by the 7 equal sides, 7 equal angles, sorry. Take 900 and divide it by 7. 128.6, we'll call that. All right, 128.6. And then if we take 180 and subtract that, 128.6, we get 51.4. Okay, multiply that by 7. What are we going to get? Should be pretty close to 360. It's probably not going to be exact because we rounded it off, but pretty close. And then, excuse me, the 1080, divide that by evenly by 8. So we take 1080, divide that by 8, and we get 135 degrees. So we take 135. Oh, sorry. We got to take 180 minus 135. That's going to leave us with what? 45 degrees. 45 degrees times 8. It's going to give us 360. So now we can come up with the general formula here. Okay. So what we did, if you remember, we just take our total sum of the angles in the polygon. So in this case, our total sum for the general formula is 180 times n minus 2. And then we're going to divide that all by the number of sides that we have, right? Because we took the 720 was, we took the 720 divided by 6, the number of sides. So the number of sides in this thing here is going to simply be n. So that's our formula. 180 times n minus 2 divided by n is going to give us a measure of each interior angle. And then what we did is we took that number and subtracted it from 180, right? So we did 180 minus this whole mess here, which is 180 times n minus 2 all over n. So that's how we found the measure of each interior angle, and the sum of all the exterior angles is 360 degrees. Okay, now this here is kind of messy, but there's a better way to do this, and I'm going to show you what that is. We know that all the exterior angles always have to equal 360. So if we want to find the measure of each exterior angle, instead of doing this mumbo jumbo, what we can simply do, and we can do that for all of these for the exterior angle, is just take 360 degrees and divide by the number of sides, which is n, right? Because like on this one here, let's say if we take 360 and divide it by 8, so we take 360 divided by 8, we get 45, which is what the measure of each exterior angle is. So this is a much better formula than that. So we're going to ditch that, and we're going to just do 360 divided by n to find the measure of each exterior angle. Okay? All right, we're going to take a look at a couple examples here to put some of this into practice, but first let's take a little comedy break. All right. Let's see. Let's take a look here. Find the interior and exterior angle measures of a regular decagon. So that is 10 sides. So we have our formulas. Here's what I'm going to suggest we do. Let's do the exterior angles first. Okay, so we can find the exterior angle, and then we will go back and find the interior angle after that. Okay, so a regular decagon has got 10 sides, so we're going to simply do 360 divided by 10 give us each exterior angle is 36 degrees, okay? And then to find the interior angle, we can simply take 180 and subtract the exterior, which in this case is 36, right? So if we do that, we get 144, don't we? Right, and then so that's going to be the interior. All right, moving along. Hexagon has exterior angles of 50, 68, 71, 57, and 62. What's the measure of the remaining exterior angle? So, since it's talking about exterior angles, we know they're always going to add up to 360. So we can simply do 360 is going to equal 50 plus 68 plus 71 plus 57 plus 62 plus the extra angle, right? And then we can just add those all up and subtract, and away we go. So we add all those up and we get 308. So we get 360 equals 308 plus x. So we're going to subtract 308 from both sides. And we get that x is going to be 52 degrees. Okay? All right, next example. A regular polygon has exterior angle measures of 30 degrees. How many sides does it have? Okay, so if the exterior angles each measure 30, so we just really have to do 360 divided by 30 is going to tell us that it's there has to be 12 of those 30-degree exterior angles to add up to 360. So that means we have 12 sides. 12 sides. It's going to have to be, this is going to have to be a 12-sided polygon. Okay? All right. Last one. A regular polygon has interior angle measures of 156. How many sides does it have? The exterior angles is, if I know the exterior angle, it's a lot easier to figure it out. So let's do this. 180 minus 156 is going to leave us with 24. So every exterior angle is going to be 24. So if we take 360 divided by 24, that's going to tell us how many sides it has to have. 360 divided by 24 leaves us with 15 sides. Okay. We could have tried that out with the other formula as well, but seems like it's always easier to figure it out once you know what the exterior angle measure is. Okay? All right, that's all we have for regular polygons and exterior angles. If you have any further questions, please feel free to ask. Thanks.